Okay, to solve this recursive function, we have to start with this inner f of 6. So we're going to solve for f of 6. And f of 6 is not greater than 10, but it is between 2 and 10. So we're going to use f of x minus 2, which is 4, plus 3. And when we solve for f of 4, it is also between 2 and 10, so we're going to get f of 2 plus 3. F of 2 is also between 2 and 10, so we're going to get f of 0 plus 3. And then f of 0 is not between 2 and 10, it is less than 2, so we're going to do 3 to the 0 times 0 to the 3. And 3 to the 0 is 1, but since we're multiplying it by 0, that answer is 0. And that's what we plug in here. 0 plus 3, which is just 3. 3 plus 3, which is 6. And then 6 plus 3, which is 9. Okay, that just tells us that now we have to solve for f of 9. So when we solve for f of 9, it is not greater than 10. It is between 2 and 10. So we will use the second equation, f of 7 plus 3. And then f of 7 is equal to f of 5 plus 3. F of 5 is equal to f of 3 plus 3. F of 3 is now below 2, so, oh, actually it isn't. So this is going to be f of 1 plus 3. And then f of 1 is now below 2, so we'll go to the bottom equation, which is 3 to the 1 times 1 to the 3. Well, that's just 3 times 1, which is 3. And then we can recursively go back, and 3 plus 3 equals 6. 6 plus 3 equals 9. 9 plus 3 equals 12. And then 12 plus 3 equals 15. Okay, so that solves this part, which is 15. So we actually need to solve for f of 15 to get our final answer. Okay, so let's do that. F of 15 is greater than 10, so we're going to use 2 times f of x minus 3, which is 12 minus 1. And then f of 12 is 2 times f of 12 minus 3 is 9 minus 1. This time we have already solved f of 9, it's 15. So I can plug in 2 times 15 minus 1, which is going to give me 29. And then when I plug f of 12 back in here, 2 times 29 minus 1, that's going to give me 58 minus 1, which is going to give me 57, which will be my final f of 15 answer.